We're going to be looking at polar coordinates today. We're normally graphing with rectangular coordinates, which are an x and a y. But today we're going to look at graphing polar coordinates, which are an r for radius and an angle, theta. Let's start off with graphing polar coordinates in radian form. And we'll just say that point A is 3 pi over 4. And I'm going to blow this circle up just a tad, because sometimes it's hard to get on the right circle if it's too small. All right, now we know where the angle pi over 4 is at. Okay, so I'm just going to kind of highlight it. If the radius is 3, that means you need to be on the third circle. So I'm going to count from the origin, and I'm going to put my point on the ray that connects pi over 4 to the origin and the third circle, and this would be where you would put point A. All right, let's go to point B. Let's say point B is negative 5 pi over 6. All right, so where is 5 pi over 6? It is in the second quadrant, so let me change colors here. So 5 pi over 6 is in the second quadrant. And the 5 denotes the fifth circle. But because the radius is negative, that is a way of denoting that you need to keep on sliding down the line, which will take you to angle 11 pi over 6, and then count to the fifth circle. So point B would end up in the fourth quadrant. So if your radius is negative, what that means is you're going to slide to the other pi over 6 angle in an alternate quadrant. Now let's look at one more point. Let's say we have point C, and I don't really want blue since my graph is blue. Let's do green. So let's say that C is 0 pi over 3. And I want to graph this point. Well, we know where pi over 3 is. Pi over 3 is in the first quadrant. Since my radius is 0, that means I can't move, even though I have an angle. If the radius is 0, you don't have a circle to move to, so you're going to stay right here at the origin. So that's where point C would be. Now, I'm going to still be graphing polar coordinates, but I'm going to actually graph in degrees. All right, so let's graph point A, 180. Remember, your first coordinate is your radius, your second is your angle, and 180 degrees is the left side of the x-axis. And since my radius is 4, I need to be on the fourth circle. So I plotted coordinate A. Now let's plot coordinate B. And B is 7, 315. So I'm just making these coordinates up, guys. All right, so 315 is in the fourth quadrant. And if I want to highlight the terminal side of that angle here, and the radius is 7 means you need to be on the seventh circle. And that's where point B is. Let's do one more. I'm going to also, like the last one, I'm going to graph a negative radius. Let's say we have negative 3, 60 degrees. 60 degrees is in the first quadrant. And if this was a positive 3, I would count to the third circle. Since the radius is negative, that means extend the line to the alternate quadrant that it extends to, which would be right here at 240. And now I'm gonna count to the third circle. All right, now I want to rename points different ways. Just like the unit circle, there are multiple angles that end up in the same location. For example, if I want another angle that is coterminal with 30 degrees, which means it's in the same location, I would just add 360 degrees, which would be 390 degrees, and I would be in the same location of 30 degrees. Or you could subtract 30 degrees. There are multiple ways to get the same angle. Sometimes we count in the negative direction to find a coterminal angle, but we're going to practice that right now. So we're going to start off in degrees, and I'm going to choose 7, 3, 15. So I'm going to call this point B, and I'm going to graph point B. Okay, and again, I'm going to blow this up so I can hit the right circle. Okay, so I've got point B. Now I want to name another point that would end up in the same location as the point 7, 3, 15. And remember, this is in degrees. So I'm going to call that B prime, and then I'll do B double prime for the other one. All right, so one way I could do it is I could consider those negative radii that I was using before. If I extend this line, it is going to be up here at angle 135. So if I have a negative radius of 7 and my angle is 135, so let's think about that. If you are up here at 135 at 7, because the radius is -7, you have to slide down to 7 in the alternate quadrant, and that will land me right on the original B. Now, another thing I could do to get a coterminal angle is, or a point that lands in the same location, I could just add 360 degrees. So if I take 315 and I add 360 to it, 675 degrees would also land in the same location as the original B. And I'm going to do one more, even though it just said find two, because this is really important that you can find these coterminal angles and these coterminal points. Let's say that I wanted to go with a negative angle. So if my radius is 7, I know that 315 is 45 degrees away from the x-axis, so I could actually say -45. So -45 would put me same place as 315, and then the 7 would land on the 7th circle. So all of those points are in the same exact location. All right, we're going to do the same thing, but I'm going to do it with radians. And I'm going to choose point A to be 3 pi over 4. If I graph 3 pi over 4, my A ends up in the first quadrant, and I want to find two additional points that are located in the same spot here. So I'll call it A prime and A double prime. All right, so I could actually consider the negative radius. So if you extend this, that takes you to 5 pi over 4. So if my angle is 5 pi over 4, and I want it to slide on the line to the first quadrant, then my radius would be -3. Now let's try to find another one. I could actually think about this as going in the negative direction. So if I go in the negative direction, this would be -pi, -3 pi over 2, and then I would add another pi over 4, so I could do that if I wanted to, or I could just add 2 pi to this. So let's do that. So if I take 5 pi over 4, I think I'm going to take pi over 4. That would be easier. If I take pi over 4 and add 2 pi, 2 pi is the same thing as 8 pi over 4, and that would give me 9 pi over 4. So if my radius is 3 and I'm at 9 pi over 4, which means you're around the unit circle 1 revolution, and my radius is 3, I'll still end up in the same location. All right, now we're going to talk about converting polar points to rectangular points to polar points. Now to do this, I am actually going to use a version of the unit circle. So if we think about the unit circle, and I'm just going to draw on this line right here, it'd be easier probably, maybe. And I actually think about a circle, and I'm going to put a triangle in the circle just like I did when I was developing the unit circle. I know the distance from the origin to the right is x, the distance straight up is y, and because I'm on the circle, the distance from the origin to a point on the circle is r. So if I take this triangle out of context and blow it up to this one here, the diagonal would be r, the horizontal would be x, the vertical would be y, and the angle is always sitting at the origin. So my angle would be in the left corner here. From that triangle, I'm going to use some familiar theorems that you already know. The first that I'm going to use is the Pythagorean theorem, which is x squared plus y squared equals r squared. Then I'm going to use SOHCAHTOA. Now I know that SOHCAHTOA, I need my opposite side, my hypotenuse, and my adjacent. If theta is my angle, x is adjacent, y is opposite, and r is hypotenuse. If I want to write the sine ratio, sine is opposite over hypotenuse, which is y over r. Cosine is adjacent over hypotenuse, which is x over r. And I really shouldn't be surprised that the y goes with the sine and the x goes with the cosine. That's always the way it is. And then tangent theta is opposite over adjacent, which is y over x. All right, so these are the things I'm going to use to convert from polar to rectangular. Let's keep in mind, polar is a radius and an angle, which we call theta. And if you want to convert to rectangular, that means you have to find the x and the y that corresponds to it. If I'm going from rectangular to polar, I'm doing just the reverse. I'm finding an x, or I have an x and a y, and I'm going to take it, convert it to an r and a theta. Now, what am I going to use? Well, to go from polar to rectangular, I'm definitely going to use the Pythagorean theorem. I'm going to use the fact that if I take this cosine theta equals x over r and solve it for x, then x would equal r cosine theta. If I take sine theta equals y over r and multiply both sides by r and solve for y, I'll get y equals r sine theta. And then sometimes I use tangent. So tangent of theta equals y over x. To go from rectangular to polar, still sometimes I use the Pythagorean theorem. And then I normally use what's already written here, which is sine of theta equals y over r, cosine of theta equals x over r, and tangent of theta equals y over x. And remember, I've got all of these 4 theorems from the theorems I already knew. Let's practice. I want to convert polar to radian. So if I want to convert polar to radian, let me come up with a rectangular point. Let's just say it's 7, 4. Now I want you to think about this. 7, 4 is in the first quadrant, so my angle needs to also be in the first quadrant. Since I'm in radian, you know that we have 0, pi over 2, pi, and so on. A lot of times I end up with a value that is not on the unit circle, and I'm going to have to use a calculator, and once in a while, I'll end up with a familiar ratio. The first thing you want to do is we have an x and a y, and we want to convert to r and theta. Let's find our radius. 7 squared plus 4 squared equals the radius squared. I'm just using the Pythagorean theorem here. 49 plus 16 equals r squared. R squared is going to equal 65, so r will equal the square root of 65. I'm halfway there, guys, because I know my r. Now I just need my theta. What I'm going to do is I'm just going to choose my favorite trig function, whether it's sine, cosine, or tangent. Let's say my favorite trig function is sine. And I'm going to use the fact that sine of theta is y over r. Sine of theta equals, now my y, we can look over here at our original point is 4. My radius I found is the square root of 65. And I know that if I want to find theta, and sine and theta are attached together, then I have to use inverse sine on both sides. So I'm going to inverse sine the left and inverse sine the right. And 4 over the square root of 65 is not something that's on my traditional unit circle, so I am going to type this in the calculator. Make sure you are in radian mode. And if you type inverse sine 4 over the square root of 65, you're going to get 0.519. Now you may be thinking, wait a minute, is 0.519 in the first quadrant? Because 7, 4 is in the first quadrant. Well, pi over 2 is actually 1.57. So from 0 to pi over 2, which means 0 to 1.57, 0.519 would be in the first quadrant. All right, so my answer is square root 65, because that's my radius, and my angle is 0.519. Now we're going to convert to rectangular. If I'm going to convert to rectangular, I will be given a polar point, which will be in some kind of r theta form, and I've got to convert this to an xy form. I'm going to use the point -3, 4 pi over 3. Where would that be at? Well, 4 pi over 3 is in the third quadrant. Since my radius is 3, that slides me up the line, and that takes me to the first quadrant. So it will be somewhere in here on the third circle. Maybe that's the third circle right there. All right, so we are going to convert to an x and a y. If you look up here at our original information, if we're going from polar to rectangle, I'm going to use the fact that x equals r cosine theta. And I'm going to put in my information. My radius is -3, cosine of 4 pi over 3. And I want you to use your unit circle. Cosine of 4 pi over 3 is -1/2. -3 times -1/2 is +3/2. To find the y, I'm going to use y equals r sine of theta. My radius is still -3. My angle is 4 pi over 3. The sine of 4 pi over 3 is negative square root 3 over 2. Y will equal, if you put the -3 over 1, that's going to be +3 square root 3 over 2. That means that my rectangular point, the x-coordinate is 3/2, and the y-coordinate is 3 square root 3 over 2. This x and y are both positive, which means you will end up in the first quadrant, which matches the original polar point. All right, now how do you graph a polar graph. So this graph is actually saying that theta is equal to r. Well, if theta is equal to r, that means that all of these, if the angle is 30 degrees, the radius will be 30. If the angle is 45, the radius will be 45. If the angle is 60 degrees, the radius will be 60. So I'm just going to fill this out. And I'm going to graph this. Now I'm going to have to adjust the scale of my circles, and I'm going to use a scale of 30 degrees. So each ring is 30, and half a ring will be 15. So if I'm going to graph 30 degrees, 30. All right, so here's 30 degrees. So remember, each ring is going to count a distance of 30. So 30 degrees 30 would end up, let me blow this up because it starts looking kind of close. There's 30. I don't know why this is so hard for me. There we go. When it gets so close, sometimes the circles start running together. All right, 45, 45. So I got my 45 degree. And if I look at it, I'm going to have to go about half in between here. All right, 60, 60. So 60 degrees will be on since I'm counting in 30s, will be on the second circle. 90 degrees will be on the third circle because I'm going up by 30s on the circles. 120 at 120. 135 and 135. And then 150 is going to be at 150. And I'm just going to keep on graphing these points. And 180 is at 180. So 180 will be on the sixth circle. And that's what it looks so far. And that is just graphing half the circle. Now, one of the problems you're going to have to finish up is it gives you r equals theta, and it is in radians, okay? It is in radians, and if you like, you can always take your calculator and you can go ahead and just convert these to a decimal. So if I take pi over 4 and divide that out, pi divided by 4, that would be 0.785. So pi over 4, if I actually let this be each circle count as 1 like I did earlier, 0.785 might be in here, somewhere in there. Pi over 2 we said was 1.571. All right, so pi over 2 is 1.571, so 1 and a little bit more than a half. And you're going to see you're going to get the same kind of shape, but this is actually taking you all the way through to 2 pi. Okay, so let me go back to this. All right, so that is graphing polar coordinates in degrees. Then you've got to graph one in radian earlier. Now, 1 through 6 wants you to plot each of the points down here. So you're going to plot those on the circle. This is in radians. And then 3 through 8, or 3, 4, 7, and 8, is going to be in degrees. Rename the following points in 2 different ways. One with the opposite radius, so they do want you to slide down. And keep the ones that are radians and radians, and the ones that are in degrees and degrees. This is going to be like the examples on the first page. And then 13 through 16 is converting from polar to rectangular, and then you have to convert from rectangular to polar. Now, the nice thing is it tells you specifically to be in degrees in this one. So If you want to use your calculator, make sure you're in degrees. All right, so let's go to 22 and then we're going to finish this up. All right, so they have a specific equation for me, r equals 4 plus sine of theta. All right, so let's think about this. This would be 4 plus 4 sine of theta. And what is my theta this time? My theta is 3 pi over 2. All right, the sine of 3 pi over 2 is -1. So this would be 4 plus 4 times -1. And this would end up being 0. So 3 pi over 2 has a 0 radius, which means I can't go anywhere. I'm at the center. Let's put in 11 pi over 6. 4 plus 4 sine of 11 pi over 6. And you may want to use your unit circle on this. That's 11. Is 4 plus 4 times the sine of 11 pi over 6 is actually -1/2. And 4 times -1/2 is -2. 4 plus -2 is 2. So at 11 pi over 6, my radius is 2. All right, now let me do one more. I'm going to put in 0. So 4 plus 4 sine of 0. 4 plus 4 times sine of 0 is 0. And this will give me 4. So if my angle is 0, my radius is 4. Now this is one thing that's going to be really important. You need to remember the order or kind of graph as you go. 3 pi over 2, 0 is here. The next point was 11 pi over 6, 2. And these are curves, remember guys? All right, and so you don't need to draw it like a straight line. You need to curve it to that point. And then from 11 pi over 6 to 0, 4. Okay, so this is the way my curve is going so far. Okay, and I'm just going to keep filling these out. If I get something that's got a square root in it, just put it in the calculator and see what the decimal equivalent is. And make sure you connect in the right order and curve it as you go. Okay? Good luck.